Hi everyone, it's Sorkin. Today we have a problem when we are given an array which is strictly increasing order, and we are also given an integer k, and we need to find the k positive integer that is missing from the array. So what's that mean? So for example, in this case we have 2, 3, 4, 7, 11, right? And the k missing element is 1 is missing, 5 is missing, 6 is missing, and also 8 is missing, and the fifth one is 9, which is we are returning. Okay, let's take this example and work on it. So our k is equals to 5, and this is our input array. So what would be the easiest way to solve this problem? The easiest way is just we are going over our array once, and if the number is missing, for example 1 is missing, let's say 5 is missing, 6 is missing, and so on. So we are adding that to our count, and when our k is equals to the 5, which is 9, so we are returning that value. In this case, our time complexity would be of n. So can we reduce our time complexity? Can we do better than that? Yes, we can. We are going to use a binary search in this case, and our time complexity in that case would be of n, log of n. So how we're exactly going to do that? Let's do one exercise here. So let's do binary search first for our full array, right, where we have all numbers. And our mid element in this case would be here, the index of 5, right? This is our mid element. And what would the value of, so value of the mid element is 6 minus 5, which is the index here, right? It's a fifth index, minus 5. And since we are starting from 1 minus 1, so it gives us 0. So if it's a if we have all elements and we are doing a binary search, so we don't have any, so this value would minus our mid element would be equal to 0, right? So it means that if we are going to do the same exact exercise here, we can find how many elements missing before our mid element. So right, this value missing before mid element. So, and let's do that for our array. So we are starting, our left is equals to 0, our right is equals to 5, our mid element is equals to here to what? Our mid equals to 2. So we are calculating again how many elements missing before this mid element, right? How many one element is missing before mid element, so we are calculating that for, so array of mid, so which means that our 2, right, the value of 4 minus 2 minus 1 gives us 1. So it means that we have one number missing before our mid element. That's our one, that which is missing before our mid element. Now we are doing again, so since it means that it's 1 is less than k, 1 is less than k. It means that our value is located, from the right side of our array, right side of our array. So we are moving our left pointer. Left is mid plus 1, so we are moving that to 3. Our right is equals to 5. We are calculating our mid. Our mid is equals to 4. Again, we are calculating the missing elements before our mid element. Now we moved our mid element here, right? Well, we moved our mid element here, and the number of the missing elements at this point, at this index, is 6, right? So what's that mean? It means that it's more than our k, so we are moving our right pointer. So our right pointer becomes our mid. Now our left is equals to 3, our right is equals to 4, our mid is equals to 3, right? So our mid equals to 3. Again, we are calculating the number of our mid now here. So we are calculating again number of the missing before our mid elements, and it equals to 3. Yes, it indeed equals to 3 at this point, 1, 5, and the 6. So we are moving it's less than our k, we are moving our left pointer. Now we moved our left pointer, left pointer and right pointer is equals to 4, right? What it means? It means that at this point we are stopping our binary search. What can we tell at this point? At this point we can tell that at this position, right, when our index is equals to 4, at this position we have we have at least k elements that is missing in our array. So this is the k. So at this point, when our index is equals to 3, our condition satisfied this. So missing elements is less than k. So at this point, it's not. So it means that we have at least k elements. We have at least k elements that is missing in our array. At this point, we are going to return left or right, doesn't matter, plus k, which will be our result. Why? Because at this point, this index, right, it's the smallest index where we have at least k missing elements. So if we add our k, it will give us exactly the value that is missing from our array. Okay, first thing that we do here, we are initializing our left and right pointer. Then we are starting our binary search until our left is less than our right. So first we are finding a mid element, which is left plus right minus left divided by 2. And also we are finding a missing values before the mid element, which is the value of mid minus mid element minus mid index value and minus 1. If the number of the missing elements is less than k, then we are searching for our value on the right side of the array. If that is less than, then in that case we are searching on the left side of the array. So we are moving our mid, and at the end we are returning our whatever left we get, because we are adding the k value to it, because this is the smallest index where we have at least k missing values. And if we are going to add the k to that, so we will get our value, which is not, for example, in example that we have seen earlier, our left is equals to 4. If we add 5, that gives us exactly 9, which is our value. The time complexity in this case log of n, because we are using a binary search here, and the space complexity, we are not using any space, so it's constant of 1. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.